Continuing our discussion on understanding quadrilaterals, let us discuss about three more shapes here: the square, a rhombus, and a rectangle. Okay. There is much similarity between these three shapes, but there are some differences as well. So let's talk about them one at a time. Okay. So first we'll talk about the side length for each one of these shapes. Okay. For a square, as we know that all four side lengths, all four side lengths are of the same measurement, right? And so is a rhombus. We can also say that just like a square, a rhombus has all four sides are of the same length. And we also know that opposite sides are also parallel to each other in a square, in a rhombus, and also in a rectangle. And the only difference between a rectangle versus a square is that only the opposite sides are equal. Opposite sides are equal or the same length. Okay. So with that, we can say that these two sides are also of the same length, right? So the another point of difference is the included angle, or let's say interior angle. All right. Interior angle in case of a square and a rectangle between any two sides is of 90 degree, and that is the similarity between these two shapes, right? We all have studied that in the past as well. And that is where a rhombus is different from these two shapes, that included angle is not 90 degree. Okay. And then that makes another difference about the diagonal of how these shapes will have their diagonals. For a square, we say that we have two diagonals and these two diagonals will bisect each other. Okay. That's one. And also, not only they will bisect, but the angle of intersection between these two diagonals will be 90 degree. So that is how we define a square. And that is exactly how we find a rhombus as well. A rhombus has two diagonals and they will bisect each other as well. And they will also make an angle of 90 degree at the intersection point, right? And for a rectangle, they will bisect each other, and that is slightly different as compared to a square versus a rhombus, that they bisect each other, but the angle of intersection, it is not 90 degree. Okay. So with this brief introduction, you can see that there is a lot of similarity between these three shapes, but there are some points or differences as well, such as one here and one here and one here. Okay. With this given knowledge, now let us work on some problems to understand how we can use these properties to find out the unknown dimension in a geometrical shape that is given to us. Okay. Now let us take a look at this example in which we are supposed to find the value of x in this diagonal segment we are given. So what you have is a rectangle with two diagonals bisecting each other, right? And we know that by the definition of a rectangle, the line segment AC, which is a diagonal, should be equal to line segment BD. This is a property of rectangle, right? And if that is the case, and we know that when two diagonals intersect in a rectangle, they cut each other at a midpoint, right? That means the line segment BO should be half of the line segment BD, or the diagonal BD, right? And that will imply that BD is equal to twice of BO. Okay, these are the line segment. And likewise, you can say that the line segment OC should be exactly half of the diagonal AC, right? Because of the property of this intersection at the point O, which will give you that AC is equal to twice of the line segment OC. Okay, now what you do is you simply substitute this value in this equation 1, for example, and then you will find that twice of OC, okay, is equal to twice of line segment BO. Now from here you can simply cancel 2. You don't even need to carry forward anything. And we know that the line segment OC is equal to 4x minus 2, and that is equal to the line segment BO, which is x plus 4. So to solve this, all you need to do is bring this variable on one side, bring this constant on the other side. That way you will have your variables and constants separated. Okay. Now this will give you 4x, and x goes to the left, it changes its sign. So it becomes 4x minus x, which will be equal to, on the right hand side I have 4, and this negative 2 transposes to the right hand side, it becomes plus 2. Okay, That gives you 3x is equal to 6, or in other words, x is equal to 2. When I put x equal to, I get 4 times 2 minus 2, which is 6. Okay, so this line segment is 6 and this will also be 6. So with that, let us now take one more problem related to a rhombus. In this example, we are supposed to find the measure of x in the given rhombus. Now, the moment you hear the word rhombus, it already solves half of your problem, because when you say rhombus, that means the diagonals will intersect at 90 degree and they will bisect each other, right? So this is your point of intersection, and that simply means that the line segment AO is exactly half of line segment AC, or in other words, AO is equal to line segment OC, right? And AO, you know, it is 6 centimeter, which is equal to x. That's what you're supposed to find. So here is your answer right by the way of its definition. So x is 6 centimeter. So even though the problem hasn't asked us to find the value of y, but let's try to find the value of y. It should be very straightforward for you, because if you pay attention, we have this dimension OD and dimension OC, and they intersect at an angle of 90 degree, right? By the property of this rhombus, diagonal meeting point. If that is the case, you can always apply the Pythagorean theorem on this dimension and this dimension, because these two are perpendicular to each other, right? And that simply means that x square plus y square is equal to 15 square by the way of Pythagorean theorem, right? Because you have a right angle triangle here, right here. So now you already know the value of x. You simply substitute this. That implies 6 square plus y square is equal to 15 square. So this will give you that y square is equal to 15 square minus 6 square, which is equal to 225 minus 36. And that difference gives you 189. So if y square is equal to 189, that means y, by simply taking a square root, should be equal to square root of 189, and that will give you 13.74. Now with that, not only you found the value of x in the given problem statement, but you also were able to find the value of y. Okay. So with that, we will pause here for our introduction on the quadrilaterals.